Hello everyone. After a little long time, this video is supposed to record in yesterday, but somehow I missed it. So last time we discussed about memory area of the JVM. If you can remember our ball throwing example, we need to take the ball, we need to store the ball, and we need to throw the ball. So class loader, memory area, and execution engine. So now we covered memory area. We discussed about each and every room, what these rooms supposed to do, what are the responsibilities. So today I'm going to take one step ahead. Okay. So now we discussed something middle, but we did not discuss how the class comes to this memory area. Today we are going to cover that, which is class loader. If you think class loader, you may think, okay, hey, class loader is nothing but it's loading the class. What it is, we convert this compiler convert into the class file, and class loader what it should do is just take the class and load into the memory. That's how you thought, right? No, it does more job than that. It does so many things behind the scene. Class loader responsibilities mainly have three categories: loading, linking, and initialization. Loading, linking, and initialization. Again, linking is divided into three categories. Okay. So, but before that, we need to understand what the class loader is. You are correct. Main responsibility is taking the class and loading into this memory area. So, mainly we can find two type of class loaders in Java, JVM. One bootstrap class loader, second one is custom defined class loaders. So, I think we should not mix up that in this session, because if so you will get really confused. So, forget about this bootstrap or whether it's a custom class loader, just focus on class loader. So, in that case we can understand what the class loader especially do, then we can talk about all those variations. Okay, come back to the topic: loading, linking, and initialization. So let's talk about one by one separately. If we discussed about the loading part, loading, linking, and initialization, if we take this loading part, the main job, main responsibility of that is take your class file and put into the memory. But when it's going to do that, it need to do certain different things. Just imagine you have a Java class and you can Java file, you convert that to the class. Now you have a class. Now you ask JVM to load this file. So when JVM reading this file, in otherwise class loader mechanism, what it does is it take fully qualified class name, right? So you know there's a package com.krishanta.sample. whatever the package name. First it's read fully qualified class name. Also it's read about variable information. Also it's read about immediate parent information. Also it's read about whether this is a class or interface or enum. Okay. So what other things is going to read? The fully qualified name, whether it's an enum or class or interface, immediate parent, and instance variable information. So it will go and read those information and then it load into the memory area. Each and every class when it's loaded, JVM does a special thing. What it does is it create an object from class type. Don't get confused, not from your class type. There is a special type in Java called class. Okay, so data type is class. For example, let's say you have a student class or employee class. So you are going to load this employee class into JVM. So what it does is it read those information, then it create object from class type and it assign this student into that class and put it into the heap. Okay, so I'm not going to explain what heap is. You need to recall. If not, you need to go down and watch that video first. Okay, so it's very important to understand the object type is a class. It's a class type object. Okay, I will show you some coding example possible in some other video to prove that we are creating object from the class. But you need to understand one thing, that is only one object per class would create. For example, let's get our previous example. We have an employee class. Okay, so in a leave class, you create a object from the employee equal new employee. So it will load the class. Just assume this is the first time in your program. So then JVM will load this employee class. So when it load, it does check whether it has immediate parent. Okay, if so, it will load. You know that if we not specified any parent, the object would be the parent. Okay, so now what happens is whenever employee is load very first time, it create JVM create object from the class type and put this employee into that class type and storing the heap. Just assume there is a other class like a manager class. So there also you are going to create an object from the employee, but this time JVM will not create object from the class type. Okay, it's the very first time only JVM create object from the class type and it's storing in the heap. So that is all about loading. Okay, if you want to summarize this, let's try to summarize this, what this class loading will okay do. These days I'm kind of a busy, so I'm recording this video in the night, so now it's close to midnight, so that's why you can see some lights and camera shadow in the whiteboard. Don't focus on those. Okay, so we were discussing about loading part. Okay, so just the same, we have a class called employee, right, employee class. So this class, just assume it's going to refer in the manager class, and there is other class for leave. Okay, so both these place this employee class will refer. Just think, very first time in your program the manager class is referring employee, so it create new object employee equal new employee. Okay, so this very first time what JVM does is it's going to load this employee class, right? So during load it create object from class type, right, the class type object, right, let's say class, and it will assign this class information, employee class information, into this class variable and store into the heap. So next time, so your leave class is going to refer the same employee class, but this time JVM will not create any additional object in from the class type because it's already created. Okay, so we can discuss in the next section why it's create from object from here and what type of things JVM is going to do with those things. But for the moment, just understand these concepts. Now you know what the class loading part will do. In the class loader, there are 3 steps: loading, linking, and initialization. Now we already discussed about the loading. So the linking is the next part. Also, this is the part which is little complicated, and some little advanced theories are here. Let's start. So linking again divide to 3 steps: verification, preparation, and resolution. Okay, linking divided into 3 sub-steps: verification, preparation, and resolution. Then what is the verification? This is very important. If you know, I think since you are watching this video, you probably have very good understanding about software and malware and those type of like problematic coding steps. So you know that sometime you are using illegal software, licensed software illegally, you are going to crack it. People won't crack any software for no reason. They put some additional code into that your exe file, so they can take some kind of a control on your computer. But when it comes to the Java, it's not easy to do that because Java has a bytecode verifier in JVM. From there, it will exactly check whether this class is safe to execute or not. That's why you probably heard like Java is safe to execute in any environment. It can make sure, JVM can make sure this is safe to execute. How it work? When you're trying to load Java class, there is a program called bytecode verifier. It will verify whether this come from valid compiler, whether this had correct structure, and whether this class file has correct formatting. If any of these are not satisfied, JVM throw a runtime exception called verifier exception. Okay, if you ever seen a verifier exception, that is an indication that your class file is altered somewhere. So it check compiler whether this is a valid compiler who's created this class file. Is the class file in the correct format, and is this class file in the correct structure? If everything is done, then verification process is complete. Then where it go? Then it moves to preparation process. What does this preparation mean? Okay, so Java is extremely programmer friendly language. Java is very friendly programmer. So if you have experience for the assembly or Pascal Pascal is again little easy, but if you ever try to read or learn assembly kind of a language, then you will understand it's very hard. But Java is not like that. Java is a very user friendly, very programmer friendly. So what is this preparation part does? Preparation means if you use any instance level variable or static variable in your class, this preparation part will assign the default value for that. But keep in mind, this is not default value. This is a default value, but not the initial value. Okay, if you, let's say, if you have a static variable, static int a equal 10 or something, okay, this process will assign 0 for that, but not the 10. Okay, so there are default value for each variable. If it is object, it is a null, right? If it is a boolean, it's a false, it's a int, it's a 0. So those type of default value. So this preparation part, what it does is it is assigning default value for your variables. It's kind of a programmer friendly work which your JVM does. But our next part, resolution, it support for you in a more than you think. Okay, I was talking about the assembly language. There everything you need to manage manually. You need to deal with a memory address. Okay, but in Java it is not like that. You can create your class called employee or student or customer. But you may understand, when it comes to the machine language, when it comes to the machine level, there is nothing called employee or student or customer. Everything is business object, domain specific object. Let's, for example, if you are writing hospital management system, you may don't have object called student. If you are writing some application for some space navigation, then you may not have a object called employee, possibly not. So that's mean all those words are domain specific, but Java allowed you to use those domain specific word on your program. Then when it comes to JVM level, JVM don't understand who is this customer. JVM won't understand who is this employee. Then what this JVM does, before it reaches the machine level, JVM is replacing those symbolic link with the direct links. For example, let's say you have a student s equal new student. Okay, then you call some method saying preparation student, and you pass this student object there. So now in this resolution part, what JVM does is JVM replace this everywhere which you use the student with the specific memory location which reserved by this newly created student object. Right, now we discussed about loading and the linking. Okay, so now we have one more thing, which is initialization. Initialization is nothing but what it does is it will assign real value. In our previous example, int variable, now it will assign 10, and also in this phase it will execute your static block. If you place any static block on your class, that will execute. So, we gave a high level, very high level cover to this class loader subsystem. We have loading, linking and initialization. Now, it is time to talk about little more in detail of each this step, what exactly how this happen in JVM. In JVM, it's always flexible for the implementation, like they can do these phases sequentially or parallelly. But there is a limitation. JVM enforce implementation, JVM specification is enforced to the implementation. Initialization must do before each class active use. Okay, so loading, linking, preparation, everything can do whatever the order this implementation wants, but there is a rule: every class must initialize before it do its active use. So what is the active use of the class? Okay, so for example, if you create new keyword, okay, if you process new keyword, so this considered as active class, active use. For example, employee e equal new employee. When you use this new keyword, this considered active use of a class. Also, if the class has a particular static method, right, invoke static method. Okay, let's say for example you have an employee class, you have a static method called verify employee. Okay, from your company class you call, you are not creating any object. Okay, in this case you are not creating new employee, but you call something like this, employee dot verify. Without creating object, you invoke this static method. That case also it considered as active use. The third one is you can assign value for static field which is in this class. In this case also you are not creating object, but you assign value for this employee class some static field. Okay, assign value for static field. Okay, for example you means employee dot code equal k. Okay, so this also considered as active use, right? But you need to understand, you need to remember one thing: if this field is final, in that case you can't assign, but if you, even though you read this final uh, variable, in that case it won't consider as a active use. In that case this class will not load for initialization. So I'm planning to have a video maybe in this week or coming week with some coding example to understand this concept. Okay, so make sure if you are watching this video, if you are interested for this video, make sure you are following the next video, because next video would be code sample to explain this exact concept. Okay, whether this is active use or passive use. Okay, right. If it is a final field, we call as constant, because that is working in the compilation level. So in that case it will not consider to create an object. Okay, if you are accessing a final variable, then it's not required to create objects. So that's why some coding standard tools enforce you to make as a final in case if you are not replacing the value, because in that case when you access this that variable, JVM is not enforcing to create new object. If your class has a main method, okay, if your class is the initial class, if your class is initial class which has main method, then also it considered as active use. Okay, then also it considered as active use. You may not invoking these classes at all, but if you have a main method, that means JVM must have to create objects, so that is also considered as a active use. Also, if your class is, if you're using any reflection, the reflection is other framework we are not discussing here, but if you are using a reflection methods to load the class, maybe you can create a get instance type of method. Okay, so if you're using any reflection specific a reflection API to create objects, so that's also considered as active use. Finally, if JVM instantiating subclass of this class, okay, for example, let's get you have a manager class which extend from this employee. You are not creating object from the employee, but you are creating object from the manager. That case also it will create object from employee class. Okay, instantiation. Okay, in this case also it considered as an active use. Okay, all these 6 cases is considered as active use for a class in a Java. So rule is JVM have a rule, before any of these active use it must create instance from the object. It must actually create instance from the object is not exactly true, but it must go through this instantiation phase. So all others are considered as passive use, so those are not required to go through this initialization process. But if in case a class is subject to any of these from this out of these 6, it must go through this initialization process. Okay, I will ask a question from you. Obviously there is no way you to answer right now, but be honest for you and just give answer yourself. So you may know, when you initializing your child class, all the parent class get called or parent class get initialized. Why? How Java does this? What is the reason for this? Okay, if you know the answer, perfectly fine. If you don't know the answer, that's also fine, but I'm going to explain why it's initialize parent class and also how Java managed to do this. Before going to that, you need to understand there is other concepts also. Just assume, just take one example class again, employee. Okay, so this employee class. So you have instance level variable called string name int id. Okay, so then you have some method here and some other method here. Okay, so just m1 m2. I understand this is violating the syntax, but I need to save the time. This video is already a little lengthy than expected, right? So now when you compile this class, what compiler does is it create new method. Okay, so you have created 2 method, but it create new method for this class, but that method doesn't have any name. Okay, so there is a method called like this, but it doesn't have any name. Okay, it doesn't have any name, but it will create this method. What the compiler does is it will put this instance level variable into this method. Also, if you are using any static variable, that's also will go here. Okay, what will go to this method? So this is called method. Okay, so this is called method. Just easy to understand that, because you don't have a name for this. And keep in mind, don't try to access this method. In under usual conditions, developers are not privileged to access this method. Okay, so so in this case we have a 2 variable, so this will move into this method where method. Okay, whatever you understand, there's a method without a name. Okay, so also if there is any static variable, those also will move to this method. Okay, but if the particular class don't have any instance level variable, then you will not have this method. Okay, so this may be a tricky interview question. If there is a particular class that doesn't have any instance variable or static variable, then what would be inside this method? The simple answer, then you won't have this method, because the compiler will create this only and only if you have at least one instance level variable or static variable. Okay, so we were talking about this initialization process. So there are 4 ways Java can initialize its class. One, you can use a new keyword. Okay, so you can use a new keyword, there also it will create new instance. Okay, so for example, new employee. Okay, second way you can use a clone method. Okay, so you can use a clone method from existing class, existing object, you can use a clone method. So third way, you can use a reflection API, and there you can use get instance method. Okay, so get instance method also will give you new instance. Okay, and the fourth way, so you have a java dot io dot object input stream, io dot object input stream. So with this class also you can call a get object method, so there also you can create new object. So with these all 4 ways you can create new instance in Java. But now the problem is, we were discussing with this initialization process, it will assign the correct value or default value, not the default value, initial value into this variable. But now you need to understand the way it's assigned the initial value to this variable, instance variable would different based on how this being created, right? For example, if you use a clone method to create the object, so then it will get value from its parent. Okay, so it will get parent object value to assign the initial values. But if you use this object input stream, it will assign value from the input stream for all non-transient variable. Okay, all non-transient variable, it will assign initial value from this stream. All the other ways, like this way or this way, it will go through the initialization process, and initialization process will assign initial values to this variable. Okay, I know it's a little bit complicated, but if you watch this second time, so you will get understand what I'm saying. Okay, so now the point what we were discussing about, how Java go through these constructors and instantiate parent class. Okay, so if you know already, let's say get example employee class, right? So employee class, you can have a default no constructor. If you don't have any constructor, so compiler will assign one constructor which is no argument, that is called default constructor. Okay, so employee, so this is called no constructor if you specify, but if you don't create this, we call this a default constructor, which means compiler will create this constructor for you. Okay, so for this constructor, what happens is the parent class, superclass constructor is visible to this class, right? So that is must, that is a must in Java. The parent class constructor must visible, parent class Noah constructor must visible to this child class. For example, let's say you have a human as a parent class. Okay, human as a parent class. So if you not created any constructor here, that's fine, because this will create a employee. So extend human. Okay, so if you're not specifying any constructor, that's totally fine, because JVM will create constructor. But if you create a private constructor here, right, then it will be a compile error. Also, if you create other constructor without specifying default constructor, then also you can't instantiate that, because it will give you a compiler error. Okay, that's other story which we already know. So now my point, so you have an employee default constructor, and you have an employee constructor which take one argument. Okay, so now what happens is, when you compile this code, so JVM create new method called init for each of your compiler, each of your constructor. Okay, so init method. Okay, so what is inside is init method is depends on how your class structure is. For example, this employee constructor which is getting one argument, you may call this keyword. Okay, so this means it's enforced to execute default constructor. Okay, in this case, init will have code to invoke default init method. So this constructor's init method, right, and it may have it have code to, it has code to byte code to particular this constructor method. Okay, so byte code to particular constructor, right, so byte code to particular constructor. But just assume you are not specifying this keyword, right, you are not specifying this keyword. In such case, what this init method has, okay, so it has a code to invoke not this one, there is no point of invoking this one, but it has a code to invoke parent class default constructor init method. Okay, again this init method is not something created by you, it's created by compiler. What it does is, it has a code to invoke parent class of this employee class, parent class which is in this case human, default constructors init method. Okay, so parent default constructor init method, and also it has codes to initialize variable, initialize instance variable, and finally byte code for this particular constructor. So that means what is inside this init method is depends on your class structure. But the rule is, there can be three kind of codes in this init method. One, there can be a code to invoke some other constructors init method, because this not necessary to have this, but if you have other constructor, you can invoke that constructor from this constructor. Okay, so in that case, if we generally speaking, we can say init method can have a code to invoke some other constructors init method. Also, it may have a code to initialize instance variables, right. Finally, it has codes to byte codes to particular implementation. So now you can understand, right, with this type of architecture, so no matter how it's a compiler, what it does is the compile time itself, so putting reference to superclass constructor. Okay, so init is again, as we speak, like this is a programmer friendly word, but this all these are machine readable kind of a byte code, is address type. So in that case, you can see from the employee class itself, when this compiler creating this class file, I promise you to explain the class file in a later video. So whenever compile time, it create a reference to previous class, right? If you have this keyword, so it will create a reference to this, and from here to the parent class. If not, it directly call parent class init method. Okay, finally, so I understand this video is not easy to understand as my previous videos, because the concepts and theories belongs to this topic is little confusing, little advanced. And so what you can do is, I'm not telling I explain everything, because I'm trying to make this video short as possible, because otherwise you may feel boring to refer these videos. So to avoid that, I'm trying to short and sweet. So in that case, I may missed couple of things. If this is a like a kind of a physical trading, this topic may explain in a 2 hour session, but this is a kind of a 30 minutes or around video. So I'm not explain, I didn't explain everything, but what you can do is, now I'm sure you have a basic understanding. Okay, so if you're not clear, so you can go through this video again. If still not clear, so you can ask question from these comments, so I'll answer for your question, or maybe I can create other video to explain these confusing point. Or else, if you have any way to reach me, so you can directly reach me through email or some other way. So then also I can explain to you what is to answer your confusing points. And next video, I'm going to do some coding example to prove these concepts, especially initializing and the class loading events and type of thing. So stay in touch, so you can find that video, because with that video may answer some question is generating by this video. Okay, so let's meet there. Have a good time with JVM internal structures.